So we're back to the slightly more verbose version here. So we get 2 out of the 3 possibilities. But just a minor difference that will be ingrained over time. Well, what about the actual data types that Python supports? Well, we've used strings already. I just showed some integers there. Python does have its own list of data types, which is actually, at a glance, shorter than C's when it comes to the most primitive ones. In C, we saw at one point pretty much this list, and then we created some of our own. In Python, this list indeed gets a bit shorter, such that we have bools still for true false values. But as you might have glimpsed earlier, it's capital true and capital false, T and F respectively, just because. There are still floats in the world of Python. There are still ints in the world of Python. And there are strings, but they're called strs, STR for short. And there are indeed some other ones as well. But there are no doubles per se. There are no longs. Rather, Python generally uses a bit more memory. So you as the programmer don't need to worry about how many bits are being used, particularly for something like integers. So more on that before long. Good question. Are there no characters? Short answer, correct. There are no characters. There are only strings, which can be single characters and even 0 characters, because heck, that seems sufficient rather than distinguishing between one or the other. So if you want a character in Python, the best you can do is a string with a single character instead. Now, it turns out in Python there's going to be other features as well. Data structures. So just a week ago, we spent on week 5's material when looking at trees and tries and hash tables and more. Python just gives you those and other data structures built in. No longer do you implement your own spell checker with your own dictionary. You can use, as we did earlier, a set. Turns out there are dictionaries or dict objects that come with Python that you can yourself use. There are tuples, which are like x comma y values, or like latitude comma longitude, so short lists of values. There's actually lists, which are similar in spirit to C's arrays. But recall that the headache of C's arrays as of week 5 was it's not very easy to grow them or shrink them because of all of the darn memory management. Python, if you use a list, essentially gives you a linked list automatically. You don't have to think or use any memory management or pointers at all. And range, we're going to say, just gives you a range of values. If you know you want to count from 1 on up to something else, range is actually a function that can give us some of that same functionality as well. So let's perhaps take some of these out for a spin here. Let me go back to VS Code. Let me close up hello.py. And let's focus on maybe implementing a simple calculator as we did a few weeks ago. In fact, let me go ahead and open up from my distribution code from lecture today, wherein I brought in advance, and these are on CS50's website, a whole bunch of examples from earlier weeks that we already implemented together. So for instance, in week 1, we actually implemented a calculator that prompted the user for 2 ints, x and y, and then simply added them together using printf in this way, with %i as the placeholder and a second argument, which was the sum thereof. Well, if I want to implement this in Python, it's actually going to be pretty similar. So let me also run code of calculator.py. That's going to open a second tab. For the sake of comparison, let me drag this over to the right so we can see these things side by side. And now let me do this. From CS50's library, import the getInt function, which I claim exists in that library. Then let's go ahead and create a variable called x, set it equal to getInt, and pass in a prompt of x : space, just so the user knows what we're asking for. Then let's do y equals getInt and prompt the user for a y value. And then down here, let's go ahead and print out x plus y. I think it's pretty straightforward as written there. We don't mention the semicolons. We don't mention the data types. But for the most part, the logic is exactly the same. Let me run Python of calculator.py, type in 1, type in 2, and I do get back, in fact, 3. So that calculator seems actually to work. But let's get rid of CS50's library. So just as quickly as we put these training wheels on today, let's take them back off so that at the end of the week, at the end of the course, certainly you're not relying on any of these training wheels anymore. So let me get rid of this line of code at the very top, no longer using getInt. And let's do this using Python's own built-in functionality. So Python itself supports this here function called input, which, similar to getString and getInt and getFloat, takes a prompt as input. So I'm going to say x : as before. I'm going to go ahead and say input y : as before. And then I'm just going to print these both out using Python's own input function instead of CS50's getInt. Let's run Python of calculator.py again. Enter. Type in 1, type in 2. And the answer, of course, should be not 12. So what just happened here? Should still be 3. Yeah. Yeah, so it seems that x and y came back as strings. And so what's happening with the plus operator here is actually being interpreted as concatenation. So I'm really saying not 12 per se, but 1, 2 joined together. Because the variable that apparently, the return value that comes back from Python's own input function appears to be a string. That is a stir by default. Now, there are ways to fix this in Python. And in C, recall that we were able to cast some values from one to another, like ints to chars and back and forth. It's not quite as easy as that in Python because technically a string, as we know underneath the hood, has one or more characters. Maybe there's a \0 somewhere in there. Who knows how Python is doing it? But there is a function in Python called int, which takes as input a string, and it will do its best to convert that string to the actual int that resembles it. So if it's quote unquote 1, it's going to give me the actual int known as 1 and so forth. So let me do that here as well as here. Let me again run python of calculator.py, enter, 1 again, 2 again, and this time 1 plus 2 equals 3. So similar in spirit, but now I just need a new tool in my toolkit, this int function, which does that conversion for me. Now what actually is in this library? CS50's own that you may or may not want to use. So in C, we had these functions as well as some other stuff, including the actual definition of string. In Python, there are indeed strings that come with the language. They're simply called strs, str. In CS50's library for Python, though, we kept it simpler and consistent with Python, the language itself. So CS50's library for Python has getString, it has getInt, it has getFloat. These, we'll see, are still useful because just like in C, recall that if the user types in like cat or dog, when you're actually asking them for an integer, our functions prompt the user again and again and again. So these functions will do that as well. We'll soon see that the input function in Python is quite similar to getString, but it's not as tolerant of invalid input, like cat or dog. If you're actually trying to get an int or float, you're just going to see a scary error message instead on the screen, which we'll come back to before long. But this is to say the library is there to get you started, but not strictly necessary ultimately. But if you want to use those functions, you can do as before from CS50, import the name of the function. And you can do this 3 times. If for whatever reason in a program you're using all 3 of these, you can just separate them by commas in this way and import all 3 of them here at once. Or, as you might recall earlier, you can just import the name of the library. So something like import CS50, though the syntax thereafter changes a bit. Before we forge ahead to now conditionals, just comparing something side by side, and then we'll build up some more interesting programs. Questions. For the most part, it's just syntactic differences and not really fundamentally different intellectual ideas under the hood just yet. So here we are with conditionals. In Scratch, if you wanted to compare x and y as variables and say conditionally x is less than y, we converted that to C as follows. The curly braces are about to go away. The semicolon's about to go away. And there's going to be one new piece of syntax here. In Python, the same idea looks like this. What is the one piece of syntax that did get added, though, in this case? Feel free to shout it out. There's a colon suddenly, which we did not have in C. It turns out in Python, though, this is both a plus and a minus depending on your religion when it comes to white space in programs. So in C, if you were not in the habit of clicking style 50 and letting it guide you toward better formatted code, frankly, you could just left align everything in your C programs. And even though it would be a mess to read, difficult to grade, it would still work. It would still be correct, but just stylistically bad. In Python, it seems that humans over the years were just so darn frustrated by students and presumably colleagues alike formatting their code poorly that in Python, indentation matters. So if you want to execute print conditional on x being less than y, you can't just put print right below if and expect the reader and the interpreter to figure things out. You must indent by convention 4 spaces instead. You can override that and you can adopt different paradigms within your own company or school, but 4 is what style 50 would now expect. So this is to say the colon means execute conditionally everything that's indented below that as though there were curly braces instead. All right, how about something else? In Scratch, if you wanted to do an if-else, it looked like this. In C, it looked like this, which is identical except for the else block here. In Python, you can probably predict how this is going to get a little more succinct. No more semicolons, no more curly braces, no more \n's for that matter, but a colon here and a colon here. And again, indentation matters and must be consistent. 4 spaces in this case for both. Finally, if, else we did in Scratch, you can do that same thing in C, almost identical, except that we've got this else if. This is the only one that's weird, and even I forget how to spell this all of the time. In Python, the semicolons are about to go away. The new line is going to go away. The curly braces are going to go away. And we're going to misspell else if as such. So it's elif in Python, colon, which is how you would implement if, elif, else for a conditional like this. Some languages, very confusingly, use else if, where E-L-S-I-F, but no E. And I probably shouldn't have even said that because now you'll be as confused as I have been for years. But let's move on to what we can actually do now with these here strings. So we know we can use these conditionals in this way. Let's go ahead now and revisit some programs from C, but this time using some new syntax and features. So let me go back to here, VS Code. Let me open up in one window here. How about compare3.c? So this was from today's distribution code, a file called compare3.c, which we looked at some time ago. And what this program did, quite simply, is exactly what we just saw on the screen, but with a full-fledged main function and the header files and the like. But all this program does is tell us whether x is less than y or not. All right, how can we go about implementing this in Python? Pretty straightforward. Let me open my terminal. Let me do code of compare.py. For this version. Let me drag it over to the right so I can see these things side by side and hide my terminal again. Let's go ahead and import from CS50 the getInt function, just to make our lives a little easier for now. Let's use x equals getInt and prompt the user for what's x question mark, just like I did at left. Let's do y equals getInt, passing in what's y question mark, just like at left. Then let's just do if x is less than y, colon, enter. And notice VS Code is not only smart enough, but deliberately configured by us to know something about Python. So it automatically indented for me, just like C very often has too. Let's print out x is less than y, quote unquote. If x greater than y, colon, then let's print out x is greater than y, close quote. Else, colon, print out x is equal to y. So nothing different versus the slides. But you can kind of see visually just how much more compact the code is, like 11 actual lines instead of 21. So it's just eliminating a lot of distraction and clutter and tightening things up, if nothing else. Let's go ahead and run Python of compare.py, enter. Let's type in 1, type in 2, and let me just wave my hand at the reality that I'm pretty sure the code is correct and would work correctly if we typed in 2 and 1, or 1 and 1, 2 and 2, and so forth. So this is to say that comparing integers in Python logically works exactly the same way as in C. But things, recall, in Python got a little weirder when we actually tried comparing, say, strings instead. And recall that when we compared strings in Python, we had to solve a problem we encountered. The very first time we compared two strings in C, S and T, as I think I called them weeks ago, they were never the same, according to my first version of my code. Why? Why is it harder to compare strings in C?
Because the addresses, it would be pointing to the wrong address.
Exactly. So recall from week 4 where we really looked underneath the hood and we realized that, oh, a string is really a char star, which is the address of the first character in the string. So whenever you compare two strings with equals equals in C, you're really comparing the memory addresses, and those probably are not going to be the same. So even if the strings look the same, they're always different. That was a pain in the neck. We had to add in the string library and the str compare function, strcomp, strcmp. It was just a lot of work to do something so darn common. It is super common to want to compare strings. In Python, wonderfully, let me close the int-based version from C here. Let me propose here that in Python, if you want to manipulate strings, you could use CS50's own getString function, but I don't even need that. I can use the input function, as we saw earlier. So if I want to prompt the user for s equals the return value of input and just prompt them for a string like s, t equals the input function, prompt them for a string called t. In Python, wonderfully, it works the way you would hope. If s equals t, then print out, quote unquote, same, else print out, quote unquote, different. So here again, it just works the way you would hope, and you don't have to pull out your textbook or your old examples to figure out how to do something relatively straightforward conceptually, is comparing two strings. Let's do one other example that evokes a past example as well. Let me open up a program that in week 1 we called agree.c. So at left, here was a program that we wrote several weeks ago now that used the CS50 library, the standard IO library. It used the getChar function to ask the user, do you agree with some terms and conditions or whatever. And then we used this syntax, which was very new in week 1, because not only were we using equals equals, we used the vertical bars, which meant what logically? So or. So we used or to detect if someone typed in uppercase or lowercase for either y, or big Y, little y, or big N, little n as well. So in Python, let's do this instead. Code of agree.py. I'll hide my terminal window, but I'll drag this here over at left. And in the Python version of this, turns out I can do something similar as follows. So let's do s equals input and prompt the user, do you agree, question mark. Then let's say if s equals quote unquote y, or s equals quote unquote little y, then print out quote unquote agreed, just like in the C version. If s equals capital N, or s equals lowercase n, then print out not agreed, just like in the C version. And here again, we're sort of seeing just how much this condenses our code. It's working logically the same, but what are some of the differences visually? Well, there's no curly braces, there's no semicolons, there's new lines, but what is there? Like, this is why Python 2 is considered more user-friendly. If you want to express the idea of or, well, like literally write or instead of vertical bars and double ampersands and the like. So I'm using or here as well as or here. Notice there's no parentheses either around these conditionals. So we didn't see those on the slides. We don't see them here. What Python does with parentheses is that if you don't need them logically to combine Boolean expressions, just don't use them at all. You could use them here and here and here and here. But if it's not necessary, why bother further cluttering your code? You simply do not need to do it. But let's see if there's a way to improve this. Let me first run this and make sure it works as intended. Python of agree.py. Do I agree? An emphatic yes. OK, let's do a lowercase n. And agreed and not agreed are indeed the answers I get back. But this feels a little redundant, I would say. Notice that my code here is really just asking the same question twice, albeit for lowercase. And it's asking the same question twice here, albeit for lowercase, for the n as well. Well, it turns out in Python, I can actually tighten this up. Let me get rid of my C version and focus on this one. And let me go ahead and condense this further as follows. If s is in the following list of values, quote unquote y, quote unquote little y, colon. And then down here, I'm going to do the exact same thing logically. If s is in this list of comma-separated values, capital N, lowercase n, this now would achieve the same results. It's a little tighter because I'm not using or. I'm not using equals 4 times. I'm using it not at all, in fact. I'm using a new keyword, which in Python exists. In, as a preposition, is a Python keyword. Does not exist in C. But this here would be a little tighter as well. So let me go ahead and run Python of agree.py. Enter. Do I agree? Capital Y. It still works. Or if I do lowercase y, it still works. But this isn't as featureful as would be ideal, because what if the user types in, for instance, an emphatic yes in all caps? Well, now it just ignores me altogether. Now, you could go in and, of course, address that. I could do capital yes and lowercase yes. But wait a minute. What if they just capitalize the first letter? So I should really have Y-E-S. And then, well, what if their like caps lock is not working as intended? And maybe we do something like this. And now we got to do this. I mean, these are all like spelled the same, even if they're miscapitalized. So this just feels like it's becoming a mess pretty quickly. So logically, whether it's in C now or in Python, what would ideally be a better logical solution to this than enumerating all possible values that we care about? Yeah. Yeah, why don't we just change the user's input to lowercase, or equivalently, just change it to uppercase to canonicalize it, like make it the way I expect it to be, and then compare it against a much shorter finite list of values. So how do we do this? Well, in C, in the C-type library, we had a toLower function, which was handy, and we had toUpper. But in Python,